We looked a little bit at centripetal acceleration, but this is really a concept that's easiest to get once you start practicing with it. So this is going to be an example video of centripetal acceleration. On a Ferris wheel. Here we go. If I've got a Ferris wheel and it's got a radius of, let's go 20 meters. That's a pretty decent sized Ferris wheel. I'm going to say here is my Ferris wheel car, and this thing goes around this way. We can say maybe this makes one rotation in 2 minutes. I would like to find my apparent weight at the top and at the bottom. Of course, we are going to need an actual mass, so let's say 50 kilograms. There's some kind of a mechanism here that holds the whole thing in place, that's fine. So this thing's going to rotate, and I want to draw a free body diagram because that's just how these problems start. I'm going to remind myself I've got a mass of 50 kilograms. A free body diagram for at the top. I'm starting at the top. I like to draw a little bit of a curved path so that I remind myself just what's going on. I'm going to have mg pointing downward, and I'm going to have a normal force from the seat pointing up. Now the apparent weight, if you remember, that's the force that's keeping you from sinking into the ground. So the apparent weight equals the normal force. That's what I'm solving for. If I do this problem, I'm going to say upward is going to be my positive direction. This whole problem is some kind of vertical, so I don't need an x and a y. I can get away with just having the one. My sum of forces equation says that at the top I've got a normal force going up. That's the force I'm looking for. I've got minus mg, and that equals mass times acceleration. Here's where I have to be a little bit careful. It's easy in a problem like this to say that my acceleration is going to be 0 because I'm not moving relative to the seat, but I am moving. At the very top, my velocity points directly to the right. A moment later, my velocity points down and to the right, which means my velocity vector is changing. If my velocity vector is changing, then I have an acceleration, because that's what that is. An acceleration is a change in velocity, right? So my acceleration is not 0. I do have that I'm moving in a circle, and if I'm moving in a circle, my acceleration is going to be centripetal acceleration, and it's going to have a magnitude of v squared over r. What's more, it points toward the center of the circle. The center of the circle, in this case, is below me, which means this has to be a negative v squared over r. It points in the negative direction. So what I have, normal force equals mg plus negative m v squared over r, or if you like, m times g minus v squared over r. Almost there. Except I don't know my speed. I do have that one full rotation is going to take 2 minutes. I can use this to find speed. In one full rotation, the distance that I have moved is equal to 2 pi r, because that's the circumference of my circle. That takes 2 minutes. Distance over time, that looks like a speed. So I've got 2 pi times 20 meters over 120 seconds. That works out to be 1.05 meters per second. So when I plug in over here, I'm going to get my mass minus 1.05 meters per second over 20 meters. And I get a normal force, or an apparent weight at the top, of 497 newtons. On flat ground, with a mass of 50 kilograms, I would have a weight of 500 newtons, so I feel a little bit lighter at the top. Let's see what happens at the bottom. At the bottom, I can start with this same free body diagram again, just for a moment. At the bottom, what's different is that this path is no longer curved in this direction. Now my path is curved this way, which also means that my acceleration vector has to point towards the center of my circle, so it's positive. Well, what does that do to all of my equations? Not a lot, as it turns out. Right here, this acceleration vector becomes a positive. That makes this positive, this positive, this positive, and I end up with a normal force of 503 newtons when I'm at the bottom. On flat ground, I have 500. At the top, I'm a little lighter. At the bottom, I'm a little bit heavier. And if I average these two, I end up right back where I started, on flat ground. That's centripetal acceleration on a Ferris wheel.